remind each other of these things, because inevitably one of these days we're going to forget.
Yeah. Hello and welcome to Podcast.init, the show about Python and the people who make it great. We're recording today on June 17th, 2015. Your hosts as usual are Tobias Macy and Chris Patty. You can follow us on iTunes, Stitcher, or TuneIn Radio. And please give us feedback. You can leave us a review on iTunes, contact us on Twitter, send us an email at hosts@podcastinit.com, or leave a comment in our show notes. I'd just like to say, we don't have any corporate sponsorship or advertisements in the show because we are making it for the community and we respect our listeners and value your time. If you'd like to help support the show and keep it ad-free, you can find out how by visiting our website. That's podcastinit.com. Today we're interviewing Jacob Kovac about the KivEnt game engine, which is based off of the Kivi library. Jacob, could you please introduce yourself?
All right, so my name is Jacob Kovac, as you said. I'm a core developer of Kivi, one of the youngest core developers and kind of new, so I'm not really super great at it, but I'm learning. And I've been building the KivEnt engine for about 2 years now. I live in Salt Lake City, and I kind of have done a variety of freelancing and entrepreneurial programming stuff for the past few years, basically.
Very cool. So, Jacob, how did you get introduced to Python?
I graduated college in 2012, and kind of right out of college, I had started a software development company and kind of web development company is mainly what it did, but we dabbled in software a little bit with a friend from high school and 2 friends from college. At the time, I was the web designer and kind of graphic designer for the company and didn't really do a whole lot of programming, but we were running behind on a project, and I really hate missing deadlines and stuff, so I kind of just picked it up, and this was a project we were building in Kivi that was I think it was kind of like a fitness tracker designed for like middle school gym classes, to track how many push-ups and pull-ups and sit-ups and things the kids did. And so that was really my first programming experience, other than some kind of dabbling I'd done, and I took 1 class in university. But other than that, so that I kind of hit the ground running with Python with a deadline and a client we needed to please. And I've been doing it since then, actually.
That's very cool. It's definitely a good inspiration to learn something and to sort of dig in, and having a project to work on is really the best way to learn programming, is what I've found. Did you have training in graphic design from college, or is it something that you just had taught yourself before getting into the web design industry? Or
It's pretty much something I had taught myself as well. I actually went to school for economics and kind of philosophy stuff, but I've always kind of had a passion for math. In high school, I captained a math team and did lots of, that kind of stuff. Math on Saturdays and so on. And so programming kind of naturally grew out of that a little bit. And I've always had an interest in kind of the artistic side of things. And so I find that the graphic design and the programming and the math go really well together when it comes to making video games, since that's basically the 3 parts.
Very cool. Could you please give us a high-level overview of KivEnt and how it differs from other game builder frameworks like Unity or Unreal?
The first thing is that KivEnt really does 3 things for you at base. I mean, it gets more complex than this, but number 1, it gives you a way to manage the memory for your game objects so that they're stored contiguously for processing. Since when you have a game, you're really kind of looping through thousands, maybe hundreds of thousands of objects if it's a modern game, and doing all kinds of random code to all those different objects based on what they are. And so one of the number 1 things you need is for those things to be stored as contiguously in memory as possible in order to keep your processor from jumping around in memory all the time, so that you slow your loop down and you have poor performance. And so it gives you a method of contiguously managing game object memory. It introduces a new real-time focused rendering pipeline to Kivi. The Kivi pipeline has really been designed for sparsely updated things. Like in most graphical interfaces, most things are stationary until you touch them or interact in some way. And so Kivi was really designed to save battery on mobile devices and things like that, so it doesn't actually do any updating until it needs to. This is, of course, sort of not what you want for real-time graphics, since you actually know for a fact that you're going to be updating 30 or 60 times a second all of your game logic. And so a completely new pipeline, for the most part, has been introduced in KivEnt that focuses on being more performant in real-time cases. And then finally, there's kind of a bit of Python magic that allows you to have game objects that are completely manipulatable from Python, but have their actual update loop on all the game objects pretty much not touch any Python at all. Because, I think we kind of all know Python is a little slow, and it's usually fast enough is kind of the mantra going on. But for games, you don't want to have too much Python overhead, because when you do have it, it'll slow you down a lot. I recently increased the speed of our the KivEnt's rendering loop by 38 times by removing a single list lookup that was in kind of the inner loop, not even the most inner loop. Wow. But any Python at all can really hamper your ability to compute real-time kind of displays, basically. And then how does it kind of relate to Unity and Unreal? Number one, Unity and Unreal are largely 3D focused, and at the moment KivEnt is mainly 2D focused. I really would like to dive into 3D at some point, and I think we would be capable of it, but there's a lot of extra things that would need to happen to get us there. However, KivEnt does use a very similar architecture to the entity component architecture used by Unity, and I think Unreal has moved that way as well. And one of the key advantages, I think, of KivEnt is that it is pretty much Python all the way down. When we get really to the lowest level stuff, a lot of it is Python and manual pointer management and memory and stuff. But for the most part, when you write a game with KivEnt, you will be working entirely with Python constructs and Python data, with the option to dive into a deeper kind of C-level API if you want to. But the whole thing is set up to be familiar to Pythonistas, to give you the ability to build a fairly performant game, not AAA or anything, but maybe A. I sometimes tell people I'm aiming for A-level games, to be able to be built in Python, to be able to control the entire rendering loop and anything like that entirely in Python, or a little bit of Python if you really need the extra performance.
With regards to not being 3D, I don't think you should beat yourself up about that, because I think that, especially recently, there's been this whole focus in the gaming industry around, 2D has not been fully explored yet, not by a long shot, and there's so much amazing gameplay. In a way, 3D can be kind of a distraction, right? But there's this whole trend towards making really great rockin' 2D, comparatively old school for most people who were kind of brought up on a diet of 3D games productions, and they're incredible. So I think KivEnt being kind of firmly in 2D space for now is not a bug, it's a feature.
Oh yes, I love 2D games. I love that we're seeing a resurgence. I really grew up in the 90s, and so something I always think of is the fact that for my whole generation, the black and white Pokemon Red and Blue on the original Game Boy just captured our entire imagination. That world was so real, even though it's only, 16 grayscale colors and barely any art at all. And I really think it's amazing to see 2D games, and really almost all types of old kind of games, coming back with the whole indie game development thing going on nowadays. We're really starting to see a whole lot of different types of art, and there's definitely, like you said, a lot of places that are underexplored or not even explored at all, because you couldn't do some of these things back when 2D games were really in their heyday. The computers were so much less performant. You didn't have any of the modern kind of shader pipelines or any of those type of things, basically.
Or even ubiquitous internet working, right? Which is now everywhere. You can even deploy your game on your mobile device and still do multiplayer because the cellular network is everywhere. So it's really kind of it's like, as you say, this territory has not been explored, and all of the infrastructure that game developers used to be straining at the edges of in the old days, now computers are many hundreds of orders of magnitude more powerful. So all those restrictions kind of go out the window.
Yeah, and that's definitely a key thing as well, is that we're really just trying to bring some of those advancements and some of those kind of ways of thinking and ways of building games to Python, since Pygame and most of the other kind of options in the Python world are really rooted in like a very, very old school way of thinking about computer graphics that barely even deals with the GPU, really. And that's, you're not going to have a really good time, particularly if you're targeting mobile, without trying to make as good of use of the GPU as you can, basically.
Absolutely. And I just want to say real quick, with regards to the 2D versus 3D debate, that I'm old, and I, you mentioned you cut your teeth in the 90s on Pokemon. I cut my teeth in the 80s on, in television and Atari and 8-bit computers. So... And I still love and play the dickens out of some of those games because they're fabulous. And the gameplay in those things is amazing and timeless, So I just think this is all great. This trend is one that I really applaud.
I think you also sort of get the focus, because in a 2D game, you don't have all the pixels in the world. You don't have the ability to do things photorealistic. And so, especially as I've gotten older, I appreciate the focus and the ability to pick up a 2D game and understand what's going on. In a lot of modern 3D games, I feel like you sometimes are just staring at a bunch of green, gray, and brown kind of pixels, trying to figure out what thing you're actually supposed to be looking at or looking for. a lot of games, The Witcher 3 even comes to mind, have like buttons you can press to highlight the stuff you really should be looking at, because they know that's a problem. As we've tried to go for photorealism, we've lost a certain sense of focus on the game part of a game in favor of a focus on kind of the entire simulation as a whole.
Yeah, and going back to the resurgence of retro-oriented games and also the design and enchantment of older games, it's really just an example of how constraints can really bring out the best in people as they're working on a problem, because they really have to think creatively about how to create the experience that they're looking for. One of the best examples that I've heard of thinking creatively to create a game is when they were making PacMan and they were trying to figure out how to program the ghosts so that they would follow Pac-Man in an appropriate manner. What they did is they decided that Pac-Man would leave a smell trail, and so programmatically they made him leave a scent trail and the ghosts were following the scent, and that was how they were able to create the algorithm to make the ghosts follow Pac-Man. And it's just really a beautiful example of constraints leading to a really elegant solution.
Yeah, and I think constraints bring up a good point, and I think this is something that'll probably be weird for a lot of Pythonistas. KivEnt is actually built with constraints in mind. You actually have to, for instance, declare a maximum amount of game objects that are going to be in your game, and in general there's a lot of static allocation that happens. Because ultimately, if you were really going to be shipping a professional game, even if you built it with some dynamic parts, at the end of the life cycle there, you would probably go in and make a lot of the dynamic areas static, because you gain a ton of performance from that. And, so like, for instance, most games have a limit on exactly how many lights can be on scene at one time or something. Anything like that, really all over games are static constraints. And those things are... really at the forefront of KivEnt, because I think that constraints help you do better art, not worse art. And being able to set limits and work within them causes you to come up with creative solutions, as you pointed out with the Pac-Man anecdote.
For anybody who's interested in Pac-Man and the kind of detail that Tobias just gave, I'll add it into the show notes. There's a really amazing webpage that, I forget the gentleman's name, this man basically did this incredibly in-depth study of the intricacies of how Pac-Man was made and the disassembly of the code. It's called the Pac-Man dossier, and it's really great, super geeky reading. So what inspired you to create the KivEnt engine?
The game engine, actually, I referenced earlier that right out of college I had started a company. In late 2012, we kind of pivoted to trying to bring out an Android game, just a simple infinite runner. And really, and it was built with Kivi. We ran into some, it was working great on the CPU, on the desktop and on a tablet we had. but on older Android hardware, it was running terribly. It was just really sad. It just chunked and, 10 FPS and things like that. I had a Droid 1 at the time, so that's practically the first Android device, and it could barely run it at all. And the frustration the team had related to that performance problem really eventually led to it abandoning the game, and actually the team broke up and everybody went separate ways. The whole time I really was saying to myself, yes, Python is slow, but I mean, we used to do kind of more than this on Game Boys and things. Computers, especially mobile, aren't fast, but they're not slow either. I remember when I was excited to get a 200 megahertz computer so that I could run modern games at the time. We easily could do more with less, and that's really what led to KivEnt, as I started down this really long and experimental road looking for how I could build games in Python with thousands to tens of thousands of objects and hundreds of thousands of vertices and all, with major data enough to build like a kind of modern game.
Is there a particular kind of game KivEnt is particularly suited for versus any of the other popular frameworks?
It focuses mainly on 2D games, but I've tried to be relatively agnostic into what type of game can be built with it. And I mean, the basic KivEnt really provides little more than some data memory management and renderers, basically. There's additional modules that add more stuff. It really should be suitable for nearly anything. It kind of has... My interests are largely in procedural generation, kind of action-y games, so it does... The pieces that are in existence are sort of focused on solving problems I had myself. But I tried to solve them in a general way that I hope will be useful for others as well.
Does KivEnt have any particular support for multiplayer games?
I kind of consider multiplayer to sort of be out of the scope. Being built on KivEnt kind of relies on having a graphical kind of context to do a lot of stuff, and you probably would have a bad time trying to run Kivi on a server, for instance. It'll at least error out when trying to make a window and things. And so multiplayer seems to me to kind of be... You could build the client for a multiplayer game in KivEnt, but there's nothing in KivEnt right now to help you build the server or to handle pulling the data from the server into the client and stuff. You'd have to choose any of the really innumerable Python frameworks that help with that type of stuff.
That's a really good point, though, right? So KivEnt solves the problem of being a framework that allows you to dynamically move objects around the screen and handle the memory management and all the other low-level details like that. And as you say, that the server-side pieces are interacting with the server. You don't necessarily provide facilities for that, but there's no reason developers can't layer those in from other tools. And I realize I said exactly what you just said, but I guess I'm just trying to put a more positive spin on it in the sense that it's not like KivEnt is a bad framework for making multiplayer games based on what we just said. It's just that this particular piece does not encompass that functionality, right?
Yes, very much. And thank you for doing the marketing for me, by the way. But very similar to Kivi's approach, the Python ecosystem is huge and full of wonderful, wonderful libraries and various different approaches to nearly solving any problem at all. You usually have 3 to 10 options for anything you want to do in Python. And so Kivi and KivEnt try to handle graphical and input management sides of that while still giving you the full benefit of using whatever part of the Python ecosystem you love most to handle problems that are sort of ancillary to the main problem of getting data to the GPU so you have nice graphical displays.
Does the fact that KivEnt games need to run on so many platforms present any unique difficulties in the development of KivEnt?
Yes and no to some extent. Really, Kivi is wonderful at cross-platform and has solved most of the problems so that I rarely even think about how things are going to work on Windows versus Mac versus Linux or Android or whatever. There have been some times when cross-platformness, and particularly the difference in GPU vendors, have reared their ugly head, so to speak. I had a really wonderful performance enhancement that was running great on my desktop, and then I found out that it doesn't run at all on some Android and doesn't run on Intel graphics processors, and so I had to end up dumping that. So in a way, it has forced me towards trying to find the most general and best implemented way to work with GL ES2. And I mean, you don't really get many options in ES2, but there's still a little bit of area where you could choose between this function and that function, or this approach and that approach. And I've tried to find the middle ground where it's fairly performant on every system and also works everywhere, which can be a little harder than you'd think. And I've also kind of started on a little task of trying to document areas where you should be aware that like certain hardware will cause problems if you do things that you might expect you should be able to do. I have a tablet here that cannot transfer matrices larger than a mat 2x2 between the vertex and fragment shader. And for instance, there's all kinds of little gotchas like that throughout especially the Android GPU ecosystem. It's a little better on desktop where you mainly have NVIDIA and AMD. However, Intel has made a lot of headway, and they have some differences in how they handle graphics as well.
That's very interesting. And mentioning OpenGL ES, I don't know if you saw, this is kind of a tangent, but kind of not really. It seems to me that OpenGL is kind of under attack, right? And there's always been DirectX, and now Apple has come out with this Metal framework for OS X. It feels like the gaming industry in general is straining at the bit that OpenGL maybe doesn't move fast enough or doesn't have latest greatest enough support for various GPUs. Do you think the mobile space is an area where OpenGL will continue to not only survive but thrive, or is it in general destined to go the way of the dodo?
You know, I think OpenGL has a really strong history of adopting the best industry standards eventually, and modern OpenGL, any of the really good supporters, which I mean I'm stuck on ES2 because of mobile, modern OpenGL does have support for solving the same problems that modern DirectX or Apple's Metal, for instance, does. And I do also think that mobile has been a big help for OpenGL, because it is definitely dominant there. Even though Apple is sort of introducing Metal, even you'd still, to target all the devices in Apple's lineup, and especially to target all the devices in the entire mobile space when you consider all the Android devices and such, you're going to need OpenGL for the next little while at least. I mean, we just barely hit 99% OpenGL ES2, I think 2 years ago, Google said, and that's an API that's 12, 13 years old, I think, at this point. So, I mean, it'll shift slowly, and there's some very interesting things. For instance, you may have heard a little about AMD's Mantle, which has already been subsumed by Kronos, which is the company or the organization that kind of handles OpenGL and the related libraries. They've already taken that Mantle and turned it into Vulkan, which is supposedly works anywhere OpenGL 3 or ES3. I'm not really super up to date there. But so if OpenGL goes away, I think it'll still be replaced by more open technologies such as Vulkan or something like that, although I'm really skeptical we'll see OpenGL go away at all. It's got such wide support at this point that there's a lot of, even with major companies wanting to, like Apple wanting to replace it, there's a lot of momentum for them to shift. And in addition, I would point out that Microsoft made a huge, what I would consider an error in going DirectX on their mobile device, because that created a huge barrier to entry for anybody who was currently serving mobile apps on their competitors' platforms, in the sense that for instance, for any KivEnt app to work on a Microsoft device, you either have to use this kind of, I think it's still fairly incomplete. It's been years since I looked into it. The Angle API, which is supposed to translate GL to DirectX. Otherwise, we'd have to rewrite the entire graphics internals to be able to target Windows Phone with KivEnt apps. And that's a huge thing to ask when we can work everywhere else with the single graphical API, basically.
Yeah, particularly when you're talking about such a small potential pool of users as what the Windows Phone ecosystem currently supports.
Yeah, it raised a huge barrier to bringing your app to that device, because it wasn't just learning how to, get your code compiled. It was completely swapping out the graphical backend. And with the amount of users they had, there was not enough incentive for a lot of apps to switch at all, basically.
So, switching gears a bit, I hear game developers talk a lot about assets and asset formats. What kind of assets can be used with KivEnt?
All right, well, so assets really, 2D assets are fairly simple compared to 3D, where you really start dealing with lots of different model formats, and particularly when you get into materials, which materials are sort of a collection of textures that represent anything from the actual kind of colors there to how bumpy or the normals for a surface or all kinds of stuff. You can represent a lot of things as textures. And the sum total of kind of the pairing those textures with the model data and the math that'll run in the shader to actually produce your image is known as a material. And so 3D engines have a lot more to do there. KivEnt will really support any type of texture that your imaging providers for your platform for Kivi will support. I know that's kind of a throwing the answer onto Kivi there, and it does vary somewhat, but so that should work pretty well. And more excitingly, I have recently, in the next released version of KivEnt, really updated the way we represent that model data. And so it does not support anything else yet, so to speak, but it is ready to do so. You can now basically specify the vertex format that your model data is going to the GPU in, and KivEnt will automatically wrap that vertex format with a model that allows you to interact with all the data from Python and set up your custom vertex data for whatever it is you're actually trying to draw to the screen. And I'm pretty proud of that point because I think it'll help people who want to do very experimental stuff or just really anything that they can think of off the top of their head to have a very quick pipeline to go from imagining the structure of their model's data to actually specifying it in code and then working with it live in the engine.
So if this is one of those questions where it's just too hard to describe it in words and it would make no sense, feel free to say so. But can you give me an example of like a standard vertex format and how someone might want to customize it or create their own? Like, what's the use case for that new feature?
Okay, yes. So, for instance, the standard vertex format in Kivi itself, this is how almost anything you draw in a Kivi app is represented. It has two floats for the X and Y position on screen, and then it has two floats for the UV position, which is the position that in the texture file that maps to the position of that vertex on the screen. So, for instance, if we were going to draw a rectangle with a texture, like a whole image file, just any standard PNG, that would be something like, let's say it starts at the origin, so the first vertex would be 0, 0, and the first UV coordinates would also be 0, 0. And then maybe it's 50 pixels by 50 pixels. So the next vertex would be 0, 50, and the UV coordinates would be 0, 1. And so you see that's basically saying the top of this rectangle on the left side is at the position 0, 50. And in the texture that we're going to map to that rectangle, that top corner is 0% of the texture in the width department and 100% of the texture in the height department, basically.
Gotcha.
And so UV coordinates are always represented on a normalized 0 to 1 scale, and that's to do with the way the GPU actually... people who really know are going to tell me this is definitely wrong, but it basically lurks between those two positions, really. And that's how it kind of scales so that you could map the texture to either a 50 by 50 object or a 150 by 150 object, and it would still know that top corner needs to be 100% of the height, so to speak.
I see. And so other engines or other tools that people may have used might store their vertices in a slightly different representational format, and your custom vertex support means that they don't have to retool their data or convert their data. They can write a little bit of code to make their vertex format work with KivEnt.
Yes. And for instance, you also asked what would be an example of a different format. I've recently been working with procedurally generating kind of space scenes that are done without textures, so it's all just colored vertices. And in that case, the vertex format is just two floats X and Y, and then 4 byte-sized things that represent the color data, R, G, B, and A. And so in that case, you're not doing any texture lookup, you're not including those UV coordinates at all, and instead you're just having basically a color and a position.
That makes perfect sense. Thank you.
Can provide a little video to give an idea of what that would look like that you can link to people, I guess.
That would be really cool. Thank you.
So, I've heard that unit testing games is difficult and rarely done for reasons of time pressure as well as lack of determinism in the interactions. Does KivEnt provide any utilities to make this easier? And also as a corollary, how well unit tested is KivEnt itself?
At the moment, the answer to the last question there is not really. I much like most game developers, I've been too busy making things show up on the screen and testing different performance things to really get around to unit testing. But that's something that is really on my mind and something I hope to change in the next year and definitely before KivEnt 3.0, so to speak. I want to get to the point where it's really heavily unit tested and you are certain that it all works, basically. And I do think that the architecture, the entity component architecture, does a good job of kind of separating your game logic concerns to make it easier to test. Not that you can test everything, because some stuff, particularly graphical things, present very large challenges, and especially when a game is sort of a kind of... the simulation results from a whole bunch of tiny state changes, so it can be kind of hard to track any one thing. But I'm hoping to find at least a somewhat clean solution that's easily reusable by people making their own logic in the next year here, time willing, basically.
Very cool. It's funny, I don't listen to it anymore because I'm kind of out of the Xbox scene a little bit, but I used to listen to the Major Nelson podcast, which was Larry Herb, one of the Xbox community evangelists, would get a bunch of people from Microsoft together and do podcasts. And it was great. And some of the people that he would get would be Microsoft Studios SDETs, software developers in test. And a bunch of them even made their own podcast. I don't know if it's still going, called Platform Biased, which was mostly about Xbox as well. And it was very interesting because they would every once in a while drop these little tidbits about how they do automated testing of these uber complex open world 3D games. And it just really kind of fascinated me. Obviously they didn't get into too much detail, A, because that kind of detail on a podcast would put most people to sleep, and B, because they probably can't reveal a lot of it because of, legal concerns, because especially back then, Microsoft was not the pinnacle of openness, but it's definitely a fascinating problem space. And you might actually consider going back and listening to some of the platform biased episodes where they talk about that stuff.
Yeah, I've written that down, and I definitely need to learn more. I'm by no means... I haven't even gotten as far as, choosing a Python unit testing framework to use, really. So I've got a lot of research to do in that area, and it's definitely something I hope to address in the future and learn about in the first place.
So how does KivEnt handle input, and what kinds of input devices are supported?
This is definitely a question I'm going to shove back off on Kivi again. KivEnt relies entirely on Kivi to handle input, and Kivi itself is, it handles pretty much all touch inputs out there, including overlays that plug into TVs and things like that. It also handles traditional mouse and keyboard. There's kind of stub support for gamepads. You're going to be digging into the kind of details of the SDL2 provider if you really want to use that, or SDL 1.2 if you're still with Pygame for a variety of reasons, including your targeting Android. And so I also think there's actually I've heard tell of some people kind of working with, things like the Kinect camera and Kivi apps as well. I've never done that personally, but I think in general, Kivi has very good input handling, and in particular, I think their decision to kind of unify mouse and touch input as much as possible was a very powerful decision going forward as we start to see, devices that have keyboard, mice, and touchscreens, for instance.
Yeah, definitely. And when we were talking to some of the other Kivi core developers a few weeks ago, one of the things that I believe it was Mathieu started talking about was working on support for the Leap motion controller. So that would probably be really cool to see how that would play into being able to create some KivEnt games to support that kind of interaction.
Yeah, definitely. In general, this is one of those areas where Kivi is really wonderful because Matthew and the rest of the gang really go out of their way to try to handle any type of kind of cross-platform, low-level operating system concerns you would have when building something, and hiding all that behind nice Python interfaces that you don't even have to know about the operating system stuff about, really.
Also, I mean, maybe it's just me, but I kind of feel like game controllers on computers in particular are kind of a black art, right? There have been quite a lot of times, as I mentioned, I'm old and I like old games, so I end up playing a lot of these, retro platform emulators and playing games on them. And it is hard getting an actual gamepad to work reliably under OS X and have it actually be supported by the software that you're trying to use it with. It's not easy. And then if you are enough of a masochist as I am to try to actually hook up a pair of original Atari joysticks and try to make them go, that's even more difficult, which is kind of amusing given the simplicity of the device. It's just basically one 8-way switch and one button, and that's the size of it. But it's surprisingly difficult.
Yeah, it hasn't gotten much better either, even nowadays. I'm recalling specifically, I had a laptop that I had put Fallout New Vegas on. I wanted to play it on an airplane, so I decided to try to hook up my Wii U controller and control Fallout with the Wii U controller. And of course, a lot of even modern games have actually been designed with controller support specifically only for the Xbox controllers, basically, thanks to Microsoft's kind of dominance. And so I ended up, I had to install custom Bluetooth drivers. I had this program that I was manually mapping keys from the Wii U controller to the Xbox 360 controller. Actually, I couldn't even get that part to work. I ended up mapping keys to keyboard buttons and mouse axes, basically. But I mean, so even now, gamepads specifically on desktop haven't gotten much better. I hope to eventually one day, if I ever get around to the time and I really need the support for a game I'm building, to build a very nice sort of unified single control interface that will work with KivEnt that maps to basically any type of joypad I can think of, and hopefully SDL2 will help with that a little bit. But I'm not really, I'm kind of a keyboard and mouse guy. I rarely use controllers outside of Mario Kart, so it's not really been on the top of my priority list, so to speak.
Is there a built-in physics engine into KivEnt, or is that something that's pluggable?
Mostly pluggable, really. It is kind of built in. I've had it since basically the beginning. Tito Matthew Verbal from Kivi had started a long time ago a wrapper built in Python around the Chipmunk 2D library, and I kind of completed some of the parts of that. And there is a module for KivEnt called KivEnt SciMunk that includes basic support for all the physics stuff that Chipmunk 2D does, as well as a growing library of sort of systems built on top of that, things such as enabling multi-touch control of the physics objects, or steering behavior is a big thing, I think, for physics stuff, because that'll help you build a decent AI that can respond to the physics environment and stuff. And so I've kind of started that as well. So it's a work in progress, but we do have basic support in that module for the Chipmunk 2D engine. And of course, one of the major goals behind making KivEnt as modular as it is that maybe you don't like Chipmunk 2D for some reason. There's kind of a holy war in the 2D physics area between Box 2D, which is a C++ engine, and Chipmunk 2D, which is a C engine. Both of them are great, both of them are fast, both of them are really good at 2D physics. And so potentially somebody may come along and hate Chipmunk and want to build a wrapper for Box 2D instead. And I would be very happy to have that as a module for KivEnt as well.
I've read a little bit about the Particle Panda library that's available for Kivi. Does that have any applicability to the sort of space that KivEnt is working in, or is that something that's entirely on its own?
So I built Particle Panda as well. And, yeah, and Particle Panda is actually one of the major inspirations for KivEnt because Particle Panda is still really slow, and at this point it's actually dead, I believe. Google changed their TOS, and I couldn't get back in touch with the guy who actually had the Google Play account because he's out of the country, and he might not even know the password and stuff anymore. And so Google pulled it from the store, but I'm actually hoping to write a Particle Panda 2 in the next few months. And just yesterday I was working on a new version of the Particle engine that kind of was underlying that. I've rewritten that freaking particle engine 5 or 6 times now, and it's actually a driving force behind how KivEnt has changed, because handling the amount of math that must be done on the Python CPU side to update the particles, as well as the amount of data they submit to the GPU, since they're fully dynamic in the sense of scale, color, and position and rotation. So that's pretty much everything you can do in 2D. It's a fairly expensive memory-wise, submitting it to the GPU, and calculation-wise, as there's a good bit of trig going on there and things like that. And so I'm writing a new version of that right now, actually, and that's going to be another module that will be released in the next update for KivEnt.
So given the constraints that you're working with and having to support multiple platforms, are there any of the Python numerical libraries that you're able to leverage for doing any of that computation, or is it something that you have to sort of hand write all on your own from scratch?
Early on, I really wanted to use NumPy or something like that to do a lot of these calculations, but I found that it was a major headache getting the entire scientific Python stack deployed for a game, basically, and that's also a lot of extra code, really, that you probably will use a tiny amount of, basically, because those dependencies are very heavy and very interlinked with each other. And so I really want that. This is really one of the precise kind of reasons KivEnt exists, is that I had to forego most of those numerical libraries in favor of making sort of custom logic that's easy to work with and portable everywhere easily. Because when I started, NumPy was not on Android. I believe NumPy is on Android now, actually. We have a recipe for that, although I don't think we have the Fortran parts working. And of course, that's another thing, is that NumPy doesn't just wrap C stuff. It wraps Fortran. It wraps all kinds of things, basically. And so I really tried to avoid those libraries. And when you're doing kind of intensive calculations in KivEnt, you're usually storing your data in kind of raw C structs and using the C level math functions and things like that, basically.
So given that you had to rework a lot of the capabilities that you were looking for in NumPy for KivEnt, did you create that logic in such a way that it could be extracted into its own library for people who might be trying to do similar types of computations with similar constraints in terms of the platform that they're trying to work on or the resources that they have available to them?
You know, I did not cut it out directly, but I think you almost could, basically. I mean, really, the core behind this is the kind of arena allocation memory management that KivEnt does, which basically allows you to sort of even take objects of a similar type and then give them arbitrary groups. For instance, I could say for the particle engine, there's a section of memory for particles reserved for, say, 10,000 particles. And that way I know when I'm processing my particles, they're all going to be in this one section of memory tightly packed. And other than that, you're just going to be doing basic math functions outside from the C library and stuff like that. But so you could cut it out and potentially use it. I'm not certain how useful outside of the very specific concept of the entity component system that memory management solution would actually be.
Fair enough.
So how does KivEnt handle collision tracking? I ask because it's always been an area I've been fascinated by ever since the 1980s. I had an Atari microcomputer and it had Atari logo on it. And that logo language implementation had DynaTurtles. So you could make the turtle look like anything you wanted. And moreover, that language actually provided the ability to say, when I collide with another turtle, do run this blob of code. So I've always thought collision tracking was kind of a neat problem space for game writers.
Collision is definitely, one of the most mathematically intensive areas, and also one of the hardest to get right, I think, in a very general sense. And what I tell people is don't do it. I recommend people use the physics engine because Chipmunk 2D, in addition to being a physics engine, is actually a wonderful collision library that can do segment to segments, circle to circle, box to box, arbitrary polygon to arbitrary polygon, and all the permutations in between those. That's a lot of code to write. I mean, Slimbeck, who's been writing Chipmunk, has been doing it for almost a decade now, I think. And obviously some of that is physics, but some of that is also just collision math. And early on, I did write a little bit of collision math. I implemented circle, circle, circle segment, and circle box collisions. And that not only took a lot of time, it's very freaking slow in Python. There's lots of corner cases that you need to solve. And it's really something, unless you are super interested in creating a collisions and physics detection library, you should just use what somebody else has already built there, I think.
It seems like you've been very smart with the KivEnt design in the sense that you're very, very focused on solving the hard problems that would be tremendous obstacles for people wanting to write a performant 2D game in Python. And you're very careful where someone else does something hard really well that you can just layer, leverage and pop in. You do that. And I think that's really, really, really smart and good engineering for that matter.
Yeah, I definitely think that's almost any game is really going to end up being a coming together of many different middleware solutions or open libraries or whatever you end up needing, basically. And so one of the things that KivEnt has also done is try to keep this in mind and have a very clear, open, and easy pathway for taking libraries written in a variety of languages and wrapping them easily in Python so that they can be scriptable by people building games while still gaining all the advantages of using whatever library that is. And that's something where the combination of the Kivi ecosystem and Cython itself is amazing, because Cython will give you access to easily wrapping C and C++ code, and Kivi itself has the PyGenius library for wrapping Java code, and the PyObjects library for wrapping Objective-C code. And between C, C++, Objective-C, and Java, I think you have access to almost the entire software ecosystem for games, basically, with the exception of C#, I guess.
It just struck me as you were saying that how writing a game these days essentially always ends up being bringing together various pieces of kind of packaged middleware is the term you used, which is perfectly reasonable in this context. But it just struck me, again, the difference between that, the modern reality of writing games, and once again, the old school reality of writing games, right? Where it was, you sat there with your macro assembler and your memory map of your computer, and that was all you had, and that was all you could use. And so you got incredibly creative with that. And so it's very, very different that over the space of years, the nature of making a game has changed so radically.
Yeah, it's definitely become democratized in a lot of ways, and it's much easier than, you don't have to be John Carmack to come up with even a 3D game anymore, basically. It's something where that's one of the things I really sat down when building KivEnt. I knew for a fact that you would often be needing to integrate some type of middleware, and in fact, Chipmunk has basically been integrated since day one, and that's caused me to make design decisions that allow for more flexibility and significant amount of variety in how you approach creating a game object and what is the underlying actual representation of that game object versus how you want it to be interacted with from Python.
Forgive my ignorance for just a moment here, but so for instance, you integrate Chipmunk 2D, which is a C-based library for physics and collision detection and all that good stuff like that there. From a developer's perspective, if I were using KivEnt to make a game, does the Chipmunk 2D API or your wrapper of it have a compatible object representation for what you would use in KivEnt? I guess what I'm asking is, if you're designing a game, let's say you're designing Pong, right? And you have different objects interacting on the screen, like the paddles and the ball, and Chipmunk is handling the physics between them. Is the same object representation used sort of all the way down and across the board, all through the code? Or do you have to do translation between Chipmunk 2D's concept of what an object is and KivEnt's?
So to some extent, the structure of KivEnt achieves some of that abstraction, basically, and that's kind of one of the things an entity component architecture is for. For instance, in KivEnt, every single object gets, or anything that's going to be on the screen gets a position component. And a system like the SciMonk physics component or the Sublime Physics system, every update frame will actually take the position from that physics object that it calculates after performing its update step and everything, and write that out into the position component. So any other game system you make that all it cares about is that XY coordinate of where your object is at, that's all it needs to look up. It just needs to grab the position component. It doesn't need to know whether it's a physics object or whether you're determining the position manually or anything else, basically. And so one of the reasons gaming has shifted to that kind of entity component architecture, and one of the reasons I think Unity has been so successful in creating an entire ecosystem of middleware developers, is that the architecture itself enforces this sort of highly diced up functionality that means that you really don't need to know the big picture of what's going on. You just care about the data that's relevant to the calculations you're going to do. And if you're wrapping something that controls that data, you just write it out to the component just like you would if you were manually controlling it. And the rest of your game can be based off of that logic, basically.
It's almost like I realize there's still, low-level hacking going on, but it almost seems like from the game dev standpoint, what you end up with is this super incredibly high-level architecture that you're interacting with, where you're almost making it sound like you're writing code, but you're not writing low-level code at all. You're writing in terms of very abstract descriptions of things like, change the X coordinate of my ball as it moves across the screen kind of thing. And the architecture is handling a lot of the low-level work to make that actually happen.
And you have no concept of a game object like a ball or a spaceship or a gun. You just have this collection of data, and each thing with the same type of piece processes it however your game logic dictates. And it's kind of, I think, a very weird way of thinking about things for people coming from a heavily object-oriented kind of Python approach, but it is very helpful in terms of making it easier to debug your logic, because everything behaves the same regardless of what it actually is. Everything is just a different kind of grab bag of the various pieces and systems you've built. And that also gives you more creative freedom, because say you build, my traditional example is, say you've got like a building, like a house in Warcraft 2 or something, and then you've got an archer character who, can move around and can shoot a bow or whatever, and then you want a tower, which is basically kind of an archer, but it can't move, and it's kind of like a building too. That becomes immediately easy to do in an entity component architecture, because your archer is, shooting component, movement component, and graphic component, and your tower is just a graphic component, or your house is, and then your tower is a shooting component and a graphic component and no movement component.
I totally see what you're saying in a sense that people who are used to standard object-oriented construction in languages like Python would find it really difficult to deal with, but it almost makes me think that what you're describing harkens back to the original conception of object-oriented programming with entities that respond to messages, right? As opposed to having these kind of big concretely named objects, it was more about they had a word for it, but basically characteristics like I can shoot arrows or I can move, or descriptors as opposed to necessarily concrete names for things.
Yes, that's actually kind of often mentioned, is that it's really not that huge of an offshoot from object-oriented programming. It's just a more strict kind of original conception. And I believe that original conception of object-oriented programming even allowed for the idea that your objects may be storing memory very differently from the way the actual object sort of exposes its data in order to, process things more efficiently, whatever your program needs to do, and so on.
So can you tell us about some of the projects that you've seen built in KivEnt, which you're most excited by?
Most of what I'm going to share here is from one of my first and best early adopters. There's a user on GitHub and IRC named Chozabu, who has done some pretty cool stuff, including contributing Windows support for both the physics engine as well as KivEnt in general. But he has done some really interesting kind of things. I'm going to link a few things here, but also describe them. The first one is what he called KivEnt Ed, which was sort of a very rough around the edges and experimental graphical editor like Unity or Unreal have for KivEnt itself. And that's something I definitely built KivEnt to do, is to, be able to live edit and interact with all the objects dynamically while the game is running, so to speak. But it's not something I've had the time to actually work on myself, and so his kind of work on KivEnt Ed, I think, is something I really hope we have a very solid version of in the future, because I think having a graphical editor can not only make certain types of games much easier to build, but it can also lower the barrier to entry for people who are getting interested in building games in the first place. In addition, he has a pretty cool game that was built with KivEnt 1.0, so it's not nearly as performant as games that you'll build with the more modern version. But it kind of does a good job of showing off the physics calculations, and even then it runs fairly well using a much less performant version of KivEnt's architecture. So those are the two biggest projects people have really shared. I'm aware of other people who are working on things, but they haven't finished them yet, nor have they really showed me what it is they're trying to do.
I'm sure our listeners will really enjoy taking a look at those two examples of work that's been done on and with KivEnt.
I do definitely think that having an editor like KivEnt Ed goes a long way towards attracting the same kind of crowd of people that are flocking towards Unity for exactly the reasons you specify. They can take a bunch of assets and have only a moderate understanding of writing code and put a game together. And I think a lot of people, A, really enjoy that, and B, there have been actually some pretty cool, even if they are somewhat simplistic games that have come out of it. So that's very cool stuff.
Yeah, definitely. I'm a big fan of people doing art whatsoever, especially kind of amateur art, and I hope that we will continue to lower the barriers to entry. One of the things is I really don't want to have so much priority as Unity on the graphical editor kind of thing, because I'm kind of a raw code guy. I don't even really use an IDE. I just kind of type in text files, and I think it's important to leave that as a first-class citizen in terms of development as well, because especially if you're doing kind of more procedurally generated games or games where you don't really actually actively place anything manually, the graphical editor can be kind of a gimmicky thing that you don't need so much of. But I would like to support, obviously, both styles of game development in the far-flung future, so to speak.
So totally random off-the-cuff question, because you mentioned being mostly focused on entering, text, that style of programming. What editor do you use? Emacs, Vim, Sublime?
I use Sublime Text. I have since a good buddy of mine in high school recommended it. I'm really happy with it, honestly.
It's a great editor. That's great. What are some ways in which our listeners could help contribute to the project?
So number one, I really would like to see more people go out and build games with KivEnt. KivEnt grows as people actually need things. A lot of the changes that have been rolled up into what I've been calling the 2.0 version are largely related to Chozabu's projects and him continually asking me how to do something that I was like, oh man, I never really even planned on anyone doing that. Let me build support for it and things like that. Give it a go, kind of download it, check it out, try to make a game, and let me know how it went. Let me know what you found was difficult. Let me know what you would like to see in the future, and I'll try to get around to it. And in addition, just a little shout out, if you have Apple hardware, since I don't have any at all, iOS or OS X, give it a shot. Let me know what's going on, post some errors, and I can try to figure out what compilation flags or whatever we need, because in theory it should work everywhere, because it's based on Kiwi's its only dependency, and Kiwi works everywhere. But in practice, I have not heard from a single kind of Apple user that it does work, and that would be a huge weight off my mind to know if we really are as cross-platform as I hope we are to be. So if you're an Apple Pythonista, really give it a go and let me know your experience. So that would be great. Really, there's a bunch of examples inside the root KivEnt project. There's an examples folder, and all of those should run. And so if you just download and try to build KivEnt, and if it builds, that's the first thing I'd love to hear. And if it doesn't build, I'd like to see the error message, because I'm sure it's nothing more than setting a few flags or something. it would be really good to know that, because I really want to bring completely cross-platform, everywhere support for building decent 2D games to Python.
At this point in time, are there any other questions that you feel we should have asked, or any questions you'd like to ask us?
I think y'all covered some pretty good territory here, and I think that hopefully the listeners will have a pretty good overview of kind of KivEnt and an insight into what some of the stuff I was thinking about when I built it. I don't think there's anything else from me at this time.
Well, with that, we'll move into the picks. And for my first pick, I'm going to choose EIN, which is the Emacs IPython notebook project. And it is an interface to IPython notebooks that you can use within Emacs. And I've started using it recently since I started playing around with the IPython notebooks after we had Fernando Perez and Brian Granger on the show, and I've been really enjoying it. The Emacs interface is really slick and well put together, and just since I use Emacs as my primary editor, trying to do any editing in the browser was just kind of painful because of not having my key combinations available to me, and EIN really solved that pain. And basically you just start up an IPython notebook, and then you go into Emacs, tell it to connect to the notebook list, it just asks what port it's running on, and away you go. For my next pick, I'm going to choose the 7.x release of pip, because it automatically will cache packages that you download and create wheels from them. So if you're installing the same packages across multiple different virtual ends, it just really makes it run a lot faster and easier to manage. And it also makes deploying that code a lot easier to do because the wheels are already built. So you can just package up your virtual env, ship it to your production server, and be off to the races. For my third pick, I'm going to choose the book RESTful Web APIs. I've been reading that recently, and it's just a really great approach and discussion on a more correct way of building APIs that are accessible via the web, rather than the typical way that a lot of people think of REST, which is just having a resource that supports get, put, post, delete, and then having a human-readable API documentation that you have to parse to try and figure out how to write your clients. And it's really trying to introduce people to the hypermedia approach to APIs and showing that it is possible for a large portion of the semantics of the API to be machine discoverable without having to have as much of a human intervention. So definitely worth a read.
For my first pick, I'm going to pick a series. I believe it was originally TV, but we've been watching it on Netflix. It might be a Netflix-only series. I'm not sure. It's called The Killing, and it is really well written, really well acted, and really, really intense. It is heavy, I will say that. This is not like light viewing, but it's a really good story. We're enjoying the heck out of it, and I can highly recommend it. The next thing I want to pick is this awesome blog post that I stumbled over the other day called Data Science on the iPad with RethinkDB. And the reason I think that is such a great post is I have gushed before on this show about Pythonista, which is a really awesome Python programming environment for the iPad, which is basically a combination sort of IDE / iPad native UI toolkit / whatever else for the iPad, which is really exciting because that kind of, self-hosted development environment is not necessarily a common thing, or at least as well developed as Pythonista is on the iPad. But the thing that has made it interesting, but perhaps not earth-shatteringly so, in my mind anyway, is Apple's restriction on not being able to import, not having your applications not having the ability to dynamically import code. But some brilliant individual, and I should really credit him or her, but I don't have the reference on hand, has written a script called Pipsta, which you can install into Pythonista by copying and pasting it from GitHub. It's one script. You can just do the little raw mode thing there and paste it in. It's super easy. And with that script, it basically gives you pip-like capabilities for your Pythonista Python environment, so you can pip install various modules. And this guy who wrote this blog post uses that capability to do earthquake analysis using RethinkDB. It's really, really cool. It's a great post, and I'm really excited over the fact that now I can pull in random Python modules on my iPad and do more interesting work. So that's very exciting stuff. My last pick is, unshockingly, because it's what I do, a beer. I'm going to pick Left Hand Brewing's Nitro Milk Stout. As I mentioned, I've kind of been exploring other varieties of beer lately because I really kind of started out liking, pretty much only porters and stouts. But this one is just an old favorite that is really stands the test of time. It's super, super, super smooth, great malty character. It's just a great, great, great stout. And as a matter of fact, I think it is the best stout that I've ever had. So there's that. And I'll stop it at that this week. Jacob, what picks do you have for us?
All right. First, I'd like to give a shout out to the Pelican framework for static generation of blogs. I just kind of started doing a blog recently, and I'm a huge fan of. I've worked with Joomla, I've worked with WordPress, I've worked with lots of content management systems for various organizations and stuff. And I've eventually ended up being one of those type of people that just want static websites. I want nothing else. I just want to write a document that has whatever information I need in it, run a compile stage, and then be able to copy and paste that stuff into my FTP and have the website going. And Pelican does exactly that. It has wonderful theming options. I've been really impressed. I like Pelican a lot. Number 2, I will actually give a shout out for something that's releasing later this month. Terraria 1.3, I believe it is, which is, we talked about kind of retro 2D games. Terraria is sort of a 2D side-scrolling Minecraft type deal, and it is a ton of fun. And they've really done, last year or the year before, I can't even remember when their last update came out, it basically doubled the size of the game, and they don't charge DLC or expansion prices. They always just give away the new content for free, and they're a great company with a really great product. Finally, the last one, in kind of the vein of Chris's beer recommendation, last year I made a batch of red wine from Italy known as Amarone, and if you've never had an Amarone or you've never made wine, it's a great place to start. Get yourself a startup kit, get yourself a thing of Amarone. It's not very sweet at all. It's a little spicy. It's a really good Italian red.
Well, Jacob, for anybody who wants to keep in touch with you or follow what you've been up to, what's the best way for them to do that?
Let's see. I've got a blog that just kind of started, and hopefully I will be posting regularly at chaosbuffalogames.com/blog. There's not even actually a root domain site yet, so I need to get there. And then you can always email me or find me in the Kivi users chat. My email is kovac1066@gmail.com. And the Kivi chat channel is on Freenode, and it's just hashtag Kivi.
Well, Jacob, we want to thank you very much for taking the time to speak with us tonight. I'm sure our listeners want to thank you as well. It's been a lot of fun and very interesting to hear about how you can use Python to make some decently performant games. So thank you very much.
Thank y'all very much for interviewing me. It was a good time.